Hi everyone, so now we've talked about how to solve quadratics with graphing and how to solve quadratics using square roots, and now we're going to solve quadratics with a different way. It's called by factoring. So factoring is one of the tougher ways to solve quadratics, but once you get the hang of it, it goes a lot faster, and you can definitely tell what can be factored and what can't be factored, because some of these things, some quadratics can't be factored and some of them can. All of the ones that I'm asking you to do today in these examples and in your self-check can be factored. So we're just going to jump into the first example and I'll show you how to set these up. So the first example is x squared plus 8x plus 15 is equal to 0. So the first step is you have to get them all set equal to 0. Good news, all of these examples are already set equal to 0. If something isn't set equal to 0, you have to set it equal to 0 first. Okay, so there's a couple of different ways that we can factor, but I'm going to show you the easiest way that I know how to do it, and that's with what I call the box method. So in the box method, we draw a big box with 4 boxes inside of it, and you always put the first term inside the top left box and the last term inside the bottom right box. This is always how it goes. This is just our setup. Now, the goal with factoring is to find something that multiplies to be the very last number. So in this case, multiplies to be 15, and then adds to be the middle number. So in this case, adds to be 8. Now, when I say find something, I mean find 2 numbers. We have to find 2 numbers that multiply to be 15 and add to be 8. So the easiest way to do this is to come up with the factors of 15, or the number that we have to multiply by. So for 15, I could say 1 times 15 is 15. I can say 3 times 5 is 15. And let's see, that's it. Those are my only 2 sets of factors. And so now we have to decide which out of those factors, which ones of those will add to 8. And I hope that it's pretty obvious, but the 3 and the 5 are the ones that are going to add to 8. So we know that 3 times 5 is 15, but we also know that 3 plus 5 is 8. So the 3 and the 5 are kind of our answer, well, kind of our answers. So now what we're going to do with those numbers, we know that our numbers are 3 and 5. What we're going to do is put one of them up in this top right box and then the other one in the bottom left box. And it doesn't matter. I could have put the 5x on top and the 3x on bottom. It doesn't matter. So now our box is filled out. But in order to actually factor this or get it into its factors, what we're going to do is say, well, what do the bottom 2 boxes have in common? Or what could I divide those bottom boxes by? And I could divide both of them by 5. Now, what about the top 2 boxes? What do they have in common? Well, there's not a number that they have in common, but they both definitely have an x, so I can pull an x out. Okay, now we're going to do the same thing, but with the left 2 boxes. So in the left 2 boxes, they have an x in common, and then we're going to do the right 2 boxes. So in the right 2 boxes, I can divide both of those by 3. So now here's the deal. The reason why we do all of that is because what that is doing is factoring our x's. And that's just a fancy way of saying it's separating our x's. So the stuff that's over here is one of our factors, and then the stuff that's on the top is another factor. So I can actually write this out as x plus 5 from the side and x plus 3 from the top equals 0. Now, again, that's just a different way of writing what our original equation was. That's how we factor. So if I said factor this, those are your factors, you're done. But we're actually going to solve these. And once we have it factored, it's really easy to solve them, because when you have your 2 separate factors like we have now, what we're going to do is set each factor equal to 0. So I can say x plus 5 is equal to 0, and x plus 3 is equal to 0. And then we're going to solve both of those for x. So to solve the x plus 5 equals 0, I'm going to subtract 5 from each side. The 5's cancel out over here. We're just left with x is equal to 0 minus 5 is negative 5. Then over on the x plus 3 side, we're going to subtract 3 from each side. The 3's cancel out. We're left with x on the left side is equal to 0 minus 3, which is negative 3. And now I have 2 answers. X is equal to negative 5 and x is equal to negative 3. And those are my 2 answers. And like I've told you in previous videos, you're normally going to get 2 answers out of these. So you're always be looking for 2 answers. And if you end up with 1, that's great. So here are your two answers for this one. Now, let's do the next one, and we're going to set it up exactly the same way. So for the second example, we have x squared minus 5x minus 24 is equal to 0. So I'm going to use that box method again and draw a big box and put 4 boxes inside of that box. And then we're going to put the top, or the first term in the top left box and the very last term in the bottom right box. And it always comes with its sign. So because that 24 is negative, we're going to keep that negative. Now the goal is to find two numbers that multiply to be the last number, so in this case negative 24, and add to be the middle number, so in this case negative 5. And the easiest, unless you can just like spot it right off the bat, the easiest way to do this is to find the factors of what you're multiplying by. So find the factors of 24. So I could do 1 times 24 is 24. I can say 2 times 12, 3 times 8, or 4 times 6. All of these are considered factors. So now we've got to decide out of all of those, which ones could potentially add to be negative 5. Now this one's slightly different than the first example because we're dealing with negatives here. And so unfortunately, there's nothing that I add and I can say, oh, well, that gives me just right off the bat negative 5. But what if I can attach negatives to some of the numbers? Notice that you have to multiply not to just be 24, but multiply to be negative 24, which means that one of your numbers has to be negative. So I'm going to tell you this one is the 3 and the 8. But in order to add to be negative 5, our 8 has to be negative. So I can say 3 times negative 8. That gives me the negative 24 that I'm looking for. But then 3 plus negative 8, that gives me negative 5. So the 8 has to be negative in this case in order for both the multiplication number and the addition number to make sense. So I'm going to use 3 and negative 8. I put 3x in one of the boxes and negative 8x in the other box. And then we're going to say, well, what do the bottom two numbers have in common? They are both divisible by 8, but they're both divisible by actually negative 8 as well. So we want to pull the negative out. Anytime that you put a negative inside of one of the, like this box right here or this box right here, you want to pull a negative out with it. Okay, what do the top two boxes have in common? They have an x in common. What do the left two boxes have in common? Once again, they have an x in common. And then what do the right two boxes have in common? These guys, we could divide both of them by 3. Notice that I put a positive 3 out there, not a negative 3, because this 3 right here is still positive, so I don't have to pull the negative out. So now I can rewrite this equation in factored form as x minus 8 from the side and x plus 3 from the top. And then that's equal to 0. Now that we've factored it, we can set each of those things equal to 0. So x minus 8 is equal to 0, x plus 3 is equal to 0, and solve both of those. To solve the x minus 8, I'm going to add 8 to both sides. I end up with x is equal to 8. And then to solve the x plus 3, I'm going to subtract 3 from each side. 3's cancel out, I get x is equal to negative 3. And here are my two solutions. All right, let's do it again with another example. So for the third example, we have x squared minus 14x plus 40 is equal to 0. We're going to set up our box once again. The x squared goes in the top left. The 40, this time it's positive, goes in the bottom right. We're trying to multiply to be the last number. So find two numbers that multiply to be 40 and then add to be the middle number, negative 14. Once again, I'm going to find the factors of 40. So I can say that's 1 times 40, 2 times 20, 4 times 10, or 5 times 8. Those are my factors of 40. So now I've got to figure out which one of those is going to give me something that adds to be negative 14. So in this case, it's again a little bit different than the last example. We want to multiply to be a positive number, but add to be a negative number. In order for that to work, both numbers have to be negative because we know that a negative times a negative is a positive number, but a negative plus a negative is a negative number. So we want both of the numbers to be negative. And if I want to add to be negative 14, I'm going to say it's 4 and 10, but I'm going to make a negative on both of them. So negative 4 times negative 10 is a positive 40, and a negative 4 plus a negative 10 is a negative 14. So those work. So I'm going to put a negative 4x in one of the boxes, a negative 10x in another box, and then we're going to find what they have in common. So the bottom two boxes have a negative 10 in common. I can divide both of those by negative 10. I pull a negative out. Even though the 40 is positive, I'm going to pull a negative out because this 10 inside this box is negative. What do the top two boxes have in common? Oh, they have an x in common. What do the left two boxes have in common? They also have an x in common. And then what do the right two boxes have in common, or what can I divide by? It would be a negative 4. Once again, I pull a negative out because this negative 4 inside the box is negative. So now I can write this out as in factored form. X minus 10 times x minus 4 is equal to 0. Now that we have it in factored form, I can set each chunk or each factor equal to 0 and solve. So to solve the x minus 10, I'm going to add 10 to both sides. And I end up with x is equal to 10. And then to solve the x minus 4, I add 4 to each side. And I end up with x is equal to 4. So here are my two solutions. X is equal to 10 and x is equal to 4. And you could potentially double check all of these by plugging them into the original equation. You don't have to, but if you got nervous about it or you wanted to double check something like on an exam, it's definitely a good way to do it. Okay, last example. We're going to set it up exactly the same way. You're going to be sick of factoring by the time I'm done with this video. So we have x squared up in the top and then negative 18. That's our last number down in the bottom right. We're going to multiply to be negative 18, which is our last number, and add to be the middle number, which is 7. So let's think about all of the factors of 18. We've got 1 times 18, 2 times 9, and 3 times 6. Those are all of the different factors that we have. And so we're trying to find something that multiplies to be negative 18 and adds to be 7. Because we want to multiply to be a negative number, we know that one of my numbers has to be negative. And so it's going to be this 2 and 9, but in order to add to be a positive 7, the 2 has to be negative. Because negative 2 times 9 gives me that negative 18 I'm looking for, but negative 2 plus 9 gives me the positive 7 that I'm also looking for. So I'm going to put a negative 2x in one of the boxes, a 9x in another box, and then let's find out what they have in common. The bottom two boxes have a 9 in common. The top two boxes have an x in common. The left two boxes have an x in common, and then the right two boxes have a negative 2 in common, or that I could divide each of those by negative 2. So now I can write it in factored form. We have x plus 9 from the side, and then x minus 2 from the top equals 0. Once again, that's just another way to write the original equation, but now that it's in factored form, it makes it way easier to solve for x. So I'm going to set each factor equal to 0. X plus 9 is equal to 0. X minus 2 is equal to 0. And then to solve the x plus 9, I subtract 9 from each side. The 9's cancel out. I'm left with x is equal to negative 9. To solve the x minus 2 equals 0, I add 2 to each side. The 2's cancel out. I'm left with x is equal to 2. And here are my two solutions. All right, and this is how we solve quadratics by factoring.